In this video we have the integral of x multiplied by ln of x to the second power, and this one's going to involve two techniques. I'm going to start off with a u-substitution and let u equal to ln of x. Then du would equal to the derivative of ln of x, which is 1 over x dx. So this ln of x then will be the u. We're converting from the variable x to u. I need a replacement then for x. So from this right here, using your definition of log, the base here is e. So x should equal to this base e taken to the u power. So x should equal e to the u. Then I'm going to multiply through by x here. Dx then will equal to x to u. I'm also going to need an x squared here. I want everything in terms of u. So if I square both sides of this right here, I'll get an x squared. Then square both sides. So if I square this side, e to the u taken to the second power, you multiply the exponent, so this will be e to the 2u. Now we're set here. This will equal to, so now my u substitution then, this will be the integral ln of x, that'll be u. So this will be a u squared here, for this part here, or I should say that dx, first dx right here, is equal to x du. I still have this x here. And then the dx is replaced from this x du. So then this would equal to the integral. And then x times x here is x squared. I got a u squared, and I got the du. And that's why I had the x squared over here. I was looking ahead to what this was going to look like. So I don't want x's. Remember, I'm going from the variable x to u, so everything has to be in terms of u. So the x squared can be replaced by e to the u. Or e to the 2u, I should say. And you got the u squared. So just like if you had e to the 2x times x squared, you would use a integration by parts. So I've done integration by parts using the standard formula. Here, because this was going to repeat, I'm going to use what they call the DI method, or the tabular method. Where in one column I take the derivative, another column take the integral. With this one I'm going to take the derivative of u squared, because that's pretty straightforward. And then on the I column, I'm going to put the e to the 2u. That one's easy to integrate. And then we just take the derivative here. So we get derivative of u squared is 2u. Then the derivative of 2u is 2. And then the derivative of 2 is 0. We stop there. We don't have to go any further. And this was just e to the x, and the integral would just be e to the x, e to the x, e to the x, but it's e to the 2u. The integral of e to the 2u would be e to the 2u, and then the derivative of 2u is 2, so I'd have to divide that by 2. And then I'd do it again. Derivative of e to the 2u over 2 would be, again, e to the 2u. Derivative of 2u again is 2. That multiplies the 2 there. So this would be a 4. And if we do it one more, we lower this a little bit more here. So 0 here. If I integrate this again, this will give me e to the 2u. Multiply the 4 by 2, I get 8. And this is just a abbreviated or shortcut of the regular integration by parts. So signs are going to alternate. If you go back to the original formula, you'll see where you have minus the integral in that first step. So it starts off with a plus here, then a minus, and they alternate. Then it's a plus. You keep on going. We're going to stop here at 0. You get 0 there, we can stop. But if we had to go over there, there'd be another minus here. Signs alternate. And then we just multiply down the diagonals. So it'd be u squared e to the 2u over 2. So this would be u squared e to the 2u over 2, going this way. And then we go this way, minus 2u. So it's going to, the next one will be minus. Got 2 here, so this is going to reduce to u e to the 2u, and that's over 4. Then we go again. Now it's plus, so this will be plus 2 times this. Of course, you reduce the 8 to 4. So this will be a plus e to the 2u over 4. And that's going to be the constant of integration. So now we have to go back to the original variable. So let's go back to what we have over here. So keep in mind that where you have e to the 2u, so this will be an x squared here. E to the 2u will be an x squared. E to the 2u will be an x squared all the way. Any place you have an e to the 2u, you gotta replace that by an x squared. So we're gonna have equals then. And then u squared, remember u is ln of x. So for this one here, I'm gonna have, let's do the u squared first. U squared from this one right here is ln of x, quantity squared. And of course you got the 2 under here. And then u squared is x squared. Next one, minus, and again, e to the 2u, that's x squared. So put the x squared. And then the u is ln of x. And that's over 4. And let me go back to this one here, make sure I did this right. U squared multiplies this one here. I got this. This one here multiplies this, and but the 2 divides into the 4. So this should be a 2 down here. And then here 2 into the 8 is a 4. I'm going to correct this one then. This is a 2 here. Plus, again, e to the 2u is x squared. So this will be x squared over 4. And of course you have your constant of integration. So the final result then is x squared times ln of x quantity squared all over 2. And then a minus x squared ln of x all over 2. And plus x squared over 4. Now we could factor here, we have common factor here in x squared, 2, 2, and then you got 2 times 2. So we could actually factor an x squared over 2 and then put the rest of this in parentheses. Sometimes you might have to do that. Sometimes you might look at the answer in the back if you're working from your textbook and hey, it doesn't look like it. Okay, simplify. So we could factor out an x squared out of each of these, x squared over 2. I'm just going to leave it like this for now. Thanks for watching. We'll see you next time.